Hello students, welcome once again Akshar IIT Foundation classes. I am your chemistry faculty S. Mohan. Students, already we have started a topic solutions, right? So once let's have a brief revision of solution. So students, I will ask and you say the answer, right? So let's check now. Solution. What is meant by the solution here? Good. A homogeneous mixture of two or more substances is called solution. A solution, a homogeneous mixture of two or more substances is called a solution, right? And now what is binary solution? Come on, binary solution. A solution which contains only two components is called binary solution. Very good. Now in the binary solution, the two components are there. What are they termed as? Good. Solute and solvent. What is solute? Which is relatively less in quantity. What is solvent? Which is relatively more in quantity. Very good. Now apart from the binary solutions, what other solutions are what? Ternary solutions, quaternary solutions, right? Ternary means what? Which consists of three components, in which one is a solvent, two are the solutes. And quaternary means what? Which consists of four components, in which one is a solvent and three are the solutes, right? So that was the first slide. So you can see here. So a solution is a homogeneous mixture of two or more substances. It consists of two components called solute and solvent. Solute is a lesser and solvent is a larger. And binary, which consists of only two components. Ternary, which consists of three components, and quaternary consists of four components, right? So this we have done. Then come to the types of solutions. I said that based on the state of the solvent, the solutions are classified into three types: solid solutions, liquid solutions, and gaseous solutions, right? Again, every solution consists of three solutions. Like in the solid solution, solid is a solvent. Then what is the solute? Maybe solid, maybe liquid, maybe gas. So like this: solid, 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 liquid, solid, gas. Liquid, solid, liquid, 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 gas. Gas, solid, gas, liquid, gas, gas. Right? So total nine types of solutions. This we discussed in the previous class. Right? Then here this we discussed about the types of solutions. So based on the solubility, solutions are classified into three types called as unsaturated, saturated, and supersaturated. Saturated means what? A solution in which no more solute can be dissolved. No more solute can be dissolved is called saturated. In which unsaturated means what? A solution which is less than required for saturation, means what? Some more solute it can dissolve. So some more solute it can dissolve. That's called unsaturated. And supersaturated is what? A solution which is more than required for saturation. So more solute than saturation level. Till here we discussed in the last class, students, right? So today let us go to the next topic. Classification of solution based on the relative amount of solute present in a given solution. So see students, here solutions are classified in different many ways. So here one of the classification is dilute and concentrated solutions. So I hope you can go to your lab, right? When you go to the science lab, so you can see that there are two types of acids, two types of bases will be there, like concentrated acid, concentrated hydrochloric acid, or concentrated sulfuric acid. And second one, dilute hydrochloric acid, dilute sulfuric acid. Most of the students, generally in the schools, we use a diluted only. Do you know what is the difference between the dilute and concentrated? Dilute means what? A solution in which more amount of water is present, then that is called a diluted. A solution in which less amount of water is present, so that is called as a concentrated, right? So here concentrated sulfuric acid, concentrated hydrochloric acid, sulfuric acid means water. They are pure hydrochloric acids or pure sulfuric acid are there. Diluted means what? In which water is mixed. Okay, so the water mixed solutions are called diluted. So here you see a solution containing relatively very small quantity of solute. Solute is present in less quantity and the solvent is more in quantity. And here you see concentrated solution containing relatively large quantity of solute is called as a concentrated solutions, right? Then come to the aqueous and non-aqueous. I hope you know the aqueous meaning is what. Okay, aqueous means water. Water. What is the aqueous? Water. Aquarium, right? And even the small children can see some movies also, like Aquaman. One movie has come, no? So in some Prime or some Hotstar. Okay, so Aquaman. Aqua means what? Water. Waterman. Okay, so aqueous solution means water. Water solutions. So in this type, water acts as a solvent. So the solution in which water acts as a solvent is water is present in more quantity. They are called as aqueous solutions. In which water is in less quantity, means water less quantity, or some other substance, other solutions are more in quantity. They are called non-aqueous solutions, right? Example, you see if a solution that contains alcohol, you think, okay, there's a water and alcohol, and water is present in less quantity and alcohol is present in more quantity. So here, what is alcohol? Alcohol is a solvent. Water is not a solvent. Alcohol is a solvent. So such type of solutions are called non-aqueous solutions. Clear? So this is also one of the important slide. Chalo. Now then, go to any doubt in this one? Simple, no. Dilute and concentrated. Second is what? Aqueous and non-aqueous, right? Yeah, students. Now we are coming to the actual topic of the solutions. From here, now actual topic starts here. Solutions. So here you must be very careful, and everyone, I want your complete attention here only, okay, on the screen only, right? Because here, based on this, so many formulas will be there, so many formulas, right? And so many numericals also will be there. Numerical means what? Problems will be there, right? So that's what you need a complete attention, concentration from here onwards, right? Chalo. Now let's see now concentration. What is meant by the concentration? Concentration means what? The amount of solute that present in a solution of a known quantity of solution is called the concentration. Means what? For example, if you are taking 100 ml of milk, and that if you are adding 10 grams of sugar, right? So now what is the concentration? So 10% weight by volume. So how much amount? 10 grams of sugar is present in 100 grams of milk. So the percentage is how much? Weight by volume percentage? 10%, because here 10 and here 100 grams of solution is there. So in the 100 grams of solution, how much sugar is there? So that expression is called concentration. For example, simply if you want to say like now, concentration means what? For example, you are writing the test of 100 marks, right? And for example, you are getting 80 marks, right, in one subject. So here the concentration is 80%. So we can say in terms of science, okay, 80%. 80% is the concentration of your marks. For example, you think you are writing the test of only 50 marks, then you are scoring like, for example, 35 marks out of 50. Then what is the percentage? 35 marks you are scoring out of 50. Then what is the percentage? 70%, right? So we are explaining in terms of, okay, percentage there. So similarly, here also, so in the exam, how many marks you are secured out of total marks, right? So here also, how much amount of solute is present and how much amount of solvent or solution, that is called the concentration. So concentrations here, the amount of solute dissolved in a known amount of the solvent solution. Known amount means, for example, if you are going to write the test, if you are writing the test, you should know for how many marks you are going to write the test. Means the test is of how many marks, right? So that you should know, right? Similarly, here how much amount of solute is present in the solution of known solution, means how much solution is present. That is known as a concentration. Clear? So concentration. Students, here in this chemistry, concentration of the solution can be expressed in various ways. So many ways are there, so many, right? But in here we are going to discuss some few which are very important. Now once if you see on the screen, or even if you have a textbook, once you can see in your material, so I can say so many methods are there to express the concentration. Like see, mass percentage, here weight by weight, volume percentage, volume by volume, mass to volume percentage. So mass means a solute in grams, solution in milliliters or liters, volume, and volume to mass means solute in the volume and solution in the mass means grams. Parts per billion, million means what? What is 1 million is equal to? Very good. So that is 10 to the power of 6. Okay. So 10 to the power of 6 is called as a million, right? Out of 10 to the power of 6 parts, if you take in that, how many parts are there? Okay, solute is present. So that's called parts per million. This is only for traces. Traces means what? A very minute, very less number of amount of solute is present, you think. In such cases, we use ppm and ppb. Okay. So parts per million, this is parts per billion. Billion means what? Billion. 1000 billions is equal to 1 billion. Okay. 1 million is equal to what? 10 to the power of 6, I said. 10 to the power of 6 is called million. 1 billion is means what? How much it is? 1000 parts of the 1000 times of the million. So how much you will get in terms of power? Very good. 10 to the power of 9. Okay. That's called as a billion. So here these two are used in rare cases, means what? If the amount of particles, if the amount of solute is very less comparatively negligible, comparatively the amount of solution, then we can use this parts per million and parts per billion, right? And mostly, we can ppm is generally to express in the atmosphere, okay, the quality of air. So there we can, when you see the news, students, you can see the news, and finally the last they can explain about the sometimes they'll give the information about the pollution of atmosphere. Okay, so in gas, okay, how many particles of carbon dioxide is there, how many particles of sulfur dioxide is there, something it will be given. So that mostly that's expressed in parts per million and parts per billion. Okay, next is strength of solution and molarity, formality, molality, normality, mole fraction. So here I have written almost 10 are there. These 10 methods, apart from this one some other also there, but here 10. These 10 ways are there to express the concentration of the solution. Concentration of the solution means how much amount of solute is present in a given solution. That's all. One solution is given, how much amount of solute is present, right? So if you want to have a milk, so usually I'm taking the milk only because you are the student. So you generally like milk and you regularly drink the milk. Okay. So if taking some glass of milk, if someone is given the milk, then immediately you can say how much sugar you added to this one, right? How much sweeter. So here how much amount of solute is present in a given solution, that is called a concentration. So concentration, see, this many ways are there and so many formulas are there, and this time you have a lot of work to learn. But you are genius and you are brilliant, you are, so you can learn anything, right? So now see your weight to weight percentage. Weight to weight percentage means what? Two weights are there. Solute is also expressed in weight, solution is also expressed in weight. Then that is called weight to weight percentage. Okay. So weight to weight percentage. Weight, solute is this one, and weight, so this is solution. This is solute, this is solution. So weight per weight percentage. Okay. Formula is weight of solute by weight of solution into 100. Very simple. All formulas are similarly. You see here, one formula, if you know everything, you'll write very easily. See here, weight of solute by weight of solution into 100. It is simple. Okay. Like just now I told you, if you got 30 marks out of 50 marks, then what is your percentage? Okay, 50 marks. Out of 50 marks, you got 30 marks. So how can you calculate the percentage? You don't know how to calculate the percentage. So I'll get here 60%. Okay. So similarly, weight of solid by weight of solution. Weight of solid means out how many marks you got. That is 30. Out of how many marks you got? This is out of 50. Okay. Into 100. Right. Now 0, 0 cancel. 5 ones are 5 20s. So 23 is a 60. That's all. 60%. See how simple it is. It is regularly used, but here the terms, some other terms, weight, volume, this is all given, but it is very simple. Every day you can calculate. Your teacher conduct the slip test. For example, you think unit test of 25 marks. Your teacher is conducting the test of 25 marks, and you think you got some about easy calculation purpose. I'll take 20%, 20 marks. You got 20 marks. So what is the percentage? So what you do? So you got 20 out of 25. So if it is for 100, how much? So just 25 ones are 25 fours are 4 into 20, 80. So your pass marks percentage are 80. So same thing. So weight of solute means how much sugar is added, and for what weight of solution, total how much milk sugar is there, and for 100. That's all. Very simple, no? Easy. Everything. See 1, 2, 3, 4. That's what I all kept in one slide only. If one formula you can learn, all these formulas you know. Only where you need to change, you need to change your here. Weight to weight. So weight of solid by weight of solid, you know that. Now next come to us here. Volume to volume. So just you replace W by V. Weight you replace by volume. So volume of solid by volume of solution into 100. See here. Volume of solid by volume of solution into 100. Clear? Now third one you see. Weight to volume. First one should be kept to weight. Second one should be kept to volume. Same formula. This only you take. Weight to volume. So weight and down you write volume. Here you write volume over. So see weight of solid by volume of solution into 100. Right. Now what is the next one? Volume to weight. So volume to weight. Put volume here. Weight same here. So this becomes volume of solid by weight of solute into 100. How easy? Yes or no? Now then where okay, that's very easy. Now we want to find the units. See students, units are very important. You know units. Okay. In the physics sir might have told, and even in the physics you learn the units. Units is must. Okay. So for example, you see here, units means what? For example, you are going to the shop and you want to purchase some sugar, and you ask the sugar. Okay. You go to the shop and ask I want sugar. Then immediately that shopkeeper, what you ask? How much sugar you want? Then what you will say? You will say that I want 5 kgs of sugar, or 5 liters of sugar, or 5 kilometers of sugar. What you ask? 5 kgs of sugar. Yes. So that kg is called as a unit. Right. If you go to the milk shop and you want to take the milk. So if you are asking, so I want milk. Then immediate shopkeeper, what he asks? How much milk you want? Do you say that I want 5 kgs of milk? No. You ask 5 liters of milk. Yes or no? So that is called units. Okay. So here liter is called unit. Right. So here you say weight by weight. Weight is measured in kgs. Weight is measured in kgs. Here also weight is measured in kg. Kg by kg both get cancelled. So no units here. Where is that? Yeah. Mass percentage has no units. Remember that. You know, I think. For example, in the mathematics you do, somewhere 5 by 5 will come. 5 by 5 both get cancelled, no? So your weight is measured in kgs, and here also weight of the solution is made kgs. Kgs get cancelled, nothing is left here. So there is no units for the weight to weight percentage. Clear to you? Now similarly, when you come to the volume to volume, again here volume here, when numerator and denominator it has the same quantity, so that what we can do? We can cancel. So we can say that volume percentage also no unit. Mass percentage has no units, and volume percentage also has no units. Right? Now come to the weight volume percentage. Now here you see your weight is there, here volume is there. Can you cancel? You cannot cancel. No. In the mathematics you have to study that. 5x by 5y is there. Otherwise x, okay, x by y is there. Can you cancel? You cannot cancel. Right? 5 you can cancel, but x and y you cannot cancel. Yes. So here x and y, because these both are different, they are not same quantity, so you cannot cancel. So similarly a weighted down volume, you cannot cancel, right? So weight is expressed in kgs, normal SI units, and it is measured in liters. So kg per liters also you can write, or you can write grams per milliliter. If you are taking in grams, then volume can be taken as milliliters, right? Similarly, volume by weight, volume here, weight is here, whether this both same? No. Can you cancel? No. Okay. So now volume is expressed in what? ml, and weight is expressed in what? Grams. So ml by grams. Right? Those are the units. Very easy to learn this one. Okay. And here some important points are there. Here you can see here. Here weight to weight percentage is independent of temperature. Independent means what? Which is not dependent. Okay. So recent year celebrated 75 in Azadi Ka Amrit Mahotsav, Independence Day. What is Independence Day? You are not dependent on any. It means India is not dependent on any other country. Here it is own. Okay. So independent. So here it is independent of temperature, means it does not depend on the temperature. It's not depend on the temperature. But here remaining you see it depends on temperature, it depends on temperature, it depends on temperature. Why? So remember one thing, wherever the volume is there, volume, wherever the volume is there, so volume depends on the temperature. They remember, this is a simple concept. So wherever the volume is there, if volume is there, then that depends on the temperature, right? So this is the concept. Clear to you? So these formulas are very, very important, students. These are all formulas you need to learn. You need to buy hard. You need to practice. So you'll have a sums based on this one. Okay. You need to solve the sums. Any doubt here? So weight to weight, volume to volume, weight to volume, volume to weight. If you have any doubt, you can. If you want to type, you can type something. If you want to have any doubt. If you want me to explain any extra for this one. No? Chalo then, I'll go for the next slide. This parts per million and parts per billion. This also I told you. Parts per million. Million means what I said? 10 to the power of 6. 10 to the power of 6 means what? 10 to the power of 6 means what? 1 beside 6 zeros. 1, 2, 3, 4, 5, 6. Okay. Unit 10, 100, 1000, 10,000, lakh, 10 lakhs. 10 lakhs. 1 million is equal to how much? 10 lakhs. Okay. If we have 10 lakhs of particles, 10 lakhs of particles are there, in that maybe 5 or 6 some other particles are there. Total 10 lakhs of particles are there. In that only 5 or 6 some other particles are there. Then to express the concentration of these particles, we can express in terms of ppm or ppb. Right? Billion means what? Billion is what? 10 to the power of 9 I said. 10 to the power of 9. So what's meant by that? 10 to the power of 9. 10 to the power of 9 means 1 beside 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. Okay. So unit 10, 100, 1000, 10,000, lakh, 10 lakhs, crore, 10 crores, 100 crores. Okay. So 100 crores of particles are there. In that 100 crores of particles, few particles of solute are there. This is a solution. This is a solution. A solution contains unit 10, 100, 1000, 10,000, lakh, 10 lakhs. Okay. 10 lakhs solution particles are there. In that solute particles are only few are there, you think. Then we can express that concentration in terms of ppm or ppb. So parts per million, parts per billion. So that's all. So see here now. When a solute is present in trace quantities, trace means what? Very little. Trace means what? Very little. So when a solute is present in trace quantities, it is convenient to express the concentration in parts per million or parts per billion. It is the number of parts of solute per billion or billion. So mass of solute component by total mass of solution ppm. See 10 to the power of 6. Let's come m million 10 to the power of 6. And let's come billion. I would write the 10 to the power of 9. Clear? Any doubt? Students, if you have any doubt, you can ask. Okay. Otherwise, you can post. Because this is very important. So many numericals are there. I am going to explain you some numericals and you need to practice some numericals. Okay. Now come to the strength. Okay. So what is the strength now? The strength of the solution is defined the amount of solute in grams present in 1 liter of solution. In 1 liter of solution, how much amount of solute in grams present? That is called the strength. So strength is nothing but a mass of solute in grams by volume of solution in liters. Okay. And if this liters you are expressing in milliliters, you can multiply with 1000. Okay, so you know, I think 1 liter is equal to 1000 milliliters. You know, 1 liter is equal to 1000 milliliters, right? Similarly, 1 kg is equal to 1000 grams. So when you express in liters and milliliters, you need to take care that whether what is there, the liters are there or milliliters are there, kgs are there, grams are there. So you have to convert. You should know 1 gram is equal to 10 to the power of minus 3 kg, right? And 1 kg is equal to 10 to the power of 3 grams. Do you know this one, or you're confusing? So here you see, you know that 1 kg is equal to what? 1000 grams. Yes. So now is it visible? Right. So 1 kg is equal to 1000. 1000 kilometers what? 10 into 10 into 10 grams. Yes or no? 10 tens are 100, tens are 1000. Now here how many tens are there? 3 tens. So 10 to the power of 3 grams. So 1 kg is equal to 10 to the power of 3 grams. Right? Now 1 gram if you want to express in kgs, 1 gram you want to express in kgs. So 1 gram if you want to express in kgs, 1 gram if you want to express in kgs, that we write as 1 by 1000 gram, 1 by 1000 kg. 1 gram is equal to 1 by 1000 kg. So 1 by 1000 kg, how can we write? 1 by 10 into 10 into 10. So that is equal to 1 by 10 cube. So when your 10 cube is going up, it becomes 10 to the power of minus 3. Yes or no? So you might have studied in the 1 by a to the power of m is equal to a to the power of minus m in algebra. Yes or no? Right? So similarly, here 1 gram is equal to, so remember 1 gram is equal to 10 to the power of minus 3 kgs and 1 kg is equal to 10 to the power of 3 grams. So you have to, you should know how to convert from milligrams to grams or grams to kgs. Similarly, milliliters to liters, okay, liters to kiloliters, right? So this is the parts per million and strength, right? So there in the first 4 we completed, now here 2 terms, total 4 plus 2, 6 are done. Then go to the next one. Now see students, here this is very important, molarity. Molarity concept is very important. So here this is very important, right? Molarity, normality, molality, mole fraction, and of course formality is also there. But so these are the most important terminologies to explain the concentration of solution. So what is molarity? Molarity can be called as, defined as the number of moles of solute. The number of moles of solute present in 1 liter of solution. The number of moles of solute present in 1 liter of solution. 1 liter of solution is called molarity. Very simple. Number of moles of solute present in 1 liter of solution. So in simple way, moles of solute, number of moles of solute by 1 liter of solution. That's all. So that is the CF. Number of moles of solute present in 1 liter of solution. So this is called molarity. Okay. So here what are the units? Moles per liter, because number of moles of solute. Number of moles of solute, number of moles by 1 liter of solution. 1 liter of solution. So moles per liter. So this simply it is denoted by capital M also. Okay. So capital M means what? Moles per liter. Capital M means what? Moles per liter. So here the number of moles of solute. Once you repeat, you can understand. With me, you repeat. The number of moles of solute present in 1 liter of solution is called molarity, right? The number of moles of solute present in 1 liter of solution is called molarity. The units of molarity is moles per liter. Moles per liter. Okay. So moles per liter. Molarity is inversely proportional to the temperature. This is one of the important point here. Molarity is inversely proportional to the temperature. Inversely means what? If the temperature increases, molarity decreases. Inversely means what? If one quantity is increasing, if other quantity decreases, then that is called inversely proportional. In the mathematics you might have studied, right? So, as the one quantity increases, other quantity will be decreases. So, if the temperature increases, molarity decreases. If molarity increases, temperature decreases, right? So, inversely proportional temperature, right? Now, when the solution is diluted, just now I told you that diluted means what? If you add water, then the molarity also decreases. If you increase the water, the molar concentration will be decreases, right? Purity will be decreases, yes or no? So, that is it. So, mathematically, see, these are the formulas, so many formulas are there, but here you need to learn this formula is very important, very important, this one, and then come to the, this formula is important, right? Chalo, these two formulas are very important, and of course, this both are same, but here they are written like, okay, converted into like, okay, so in grams, so that's what this is also important. So, many formulas are there, 1, 2, 3, 4, 5, 6, some formulas are there, but in the students 1, 2, 3 formulas you can learn. So, molarity is equal to CF, very simple formulas here, molarity is equal to number of moles of solute, present in 1 liter of solution, volume of solution in liters, that's all. What the definition you are studying, that only you are putting in the form of formula, that is a formula, very simple, no? Very easy, so don't be confused here. Okay, this if I want to express in detail, then we can use this formula. Okay, actually we have this, I'll explain detail. Mole, number of moles is equal to weight by molecular weight, weight by gram molecular weight. So that we write here. So in the place of number of molecules, weight by molecular weight, 1000 by volume of solution in milliliters. Here liters is there, here milliliters are there. So just want to tell you, 1 liter is equal to 1000 milliliters. So to convert this, you are written by 1000 by this one. And here one more formula is also there. M1 V1 by N1 is equal to M2 V2 by N2. Here M is what? Molar, means here when we use this one is, for example, we have one solution. Okay, one solution is there and its molarity is M1. Means we are taking, for example, you think this way I am taking some 200, okay, 200 ml of some molarity solution. Okay, now in that I'll add the water. I'll add the water. Then what happens? The 200 ml becomes some 400. Does it molarity remains the same? No. For example, you are making some sharbat. You know the sharbat? Okay. So you are making some sharbat, Ruh Afza. Okay. Do you know the Ruh Afza sharbat? It's very good in the summer. So have it. So Ruh Afza sharbat you are making. So some quantity of Ruh Afza is left, and I am using that Ruh Afza and making one glass. That is 200 ml of sharbat. I made it. Okay, just about to drink, suddenly you think, one of my friend has come. Okay, so then what I do, in front of friend I can't drink, no. So, okay friend, you take this one. Then he also refused, because how can he alone drink by leaving me? So, we decided to drink 2 members. But now what we are doing is, instead of dividing into half, we add one more glass of water. You think, just imagine. Okay, one more glass of water I am adding in that. Now, first initially it is 200 ml of sharbat. Okay, I am adding one more 100 ml of 200 ml of first. Okay, I am adding something. Right. Now, is there any change in the taste, like sweetness? Okay, first one, if I add water, definitely. Okay, in first only 200 ml of sharbat was there. That was so sweet, and if you are adding more 200 ml of water, then water quantity is increased. So what happens? The sweetness is decreased. Yes or no? Very clear. Okay. So that's called molarity. So its molarity is somewhat, it's more sweetness, and volume is less. I'm adding more water. So what happens? Volume increases and sweetness decreases. Okay. So here first condition we are taking M1 V1. Second condition we are taking M2 V2. So then we apply the formula. Then we get on M1 V1 by N1 is equal to M2 V2 by N2. This is also one of the important formula. And this formula is also, if two solutions of the same solute are mixed, this is also same type of formula. Okay, so for example, we have Okay, two solutions of different concentrations, means same solutions, and we are mixing. Then to know the final concentration, then we use this formula. Okay, so this when the problems will come, I'll explain detailedly one by one. Okay, so don't worry. Now the last and final one, formality. So formality is nothing but like molarity only, but here we use the gram formula weight. This is the only difference. In the previous slide, see, weight by molecular weight into 1000 by V was there. See, weight by molecular weight into 1000 by V, volume is there. Only in the molecular weight place we are using the formula weight, gram formula weight. That's all, student. So all are similar. Here 10 terminologies I have given, all are similar, but small changes are there. Okay, very small changes are there. That small changes, if you identify, if you remember, if you distinguish them, then it is very easy to remember these formulas. Okay, so students, here with this, the first topic synopsis 1 in your textbook is done in your material. Now then, comes to the sums are there, classwork, practice sheet is there, right? This practice sheet is very easy. So we'll try. So I think only few minutes is left for us. So how many we can do it? We can do it, and remaining you try. Okay. So you can do it, because once you read the synopsis and you can do it, but everyday work every day you have to do. So see here, among the following example, liquid in solid type solution. Very simple, you only will say liquid in solid. Now see, mercury in gold, alcohol in water, camphor in air, moisture in air. So what they are asking? Liquid in solid. Mercury. Mercury, is it liquid or solid or gas? Liquid. And gold, liquid or solid or gas? Gold, solid. So this is liquid in solid. So they are asking this is only liquid in solid. So our answer is 1. So that's all. How simple is it? Yes or no? Now come to the next one. The solution of soda water. This I explained you good. Okay. The lemon soda, if you drink, they take the water and they fill the carbon dioxide gas. I said no. Okay. So here, which type of solution this is? Gas in gas, gas in liquid, liquid in gas, solid in liquid. So here what? They take the water and in that they send some amount of carbon dioxide gas. So water is more quantity, carbon dioxide is less in quantity. So carbon dioxide in water means what? Gas in liquid. So is that? Yeah, that is gas in liquid. So this is our correct answer. 2 options. Right. Now third one. Third is among the following example for solid type. Only given solid type means both should be the solid only. Solid is solid, solid is solid. Solid type, complete solid only. Now what is that once you see here? Sugar in water? No, because water is liquid. Camphor in air? No, here air.